All right, let's go ahead and start talking about these 7 problems here from Module 7. On questions 1 and 2, I'm only going to do one part, either part A or part B. But before we get into that, I want to remind you guys of something that we had written down during this module to help us. We had made a little table, and on that table, we had the sum of the angles, each angle, interior, and exterior. The sum of the interior angles is n minus 2 times 180. And for the exterior angles, the sum is always 360. For each interior angle, you do n minus 2 times 180, the sum, divided by the number of sides, divided by n. For exterior, we do 360 divided by n. All right. So on number 1, before we can find the value of x, we have to figure out what the sum is of all of these angles. There's 1, 2, 3, 4, 5, 6 angles. So this would be 6 minus 2 times 180. This is the sum of the angles. So we end up with 4 times 180, which is 720 degrees. This is what I'm going to set my equation equal to. You're going to take each one of those 6 angles. We have x, 120, 124, 160. Don't stop there. There's 2 more angles. What are those other 2 angles? 90 and 90, yes. So plus 90, plus 90. Just because there's not a number there does not mean that they're not telling you how big it is. Equals 720. Then you have to combine all of these like terms together. So I would have x plus, when you add all those up, you get 584 equals 720 degrees. And then you subtract 584 from both sides. And we get a value for x that is 136 degrees. So x is 136. I'm going to leave part B for you to do on your own, but part B you would do exactly like you do part A, except instead of having 6 angles, you have how many angles on part B? 5 angles. You have 2 90-degree angles, you have the 38-degree angle, the 282, and x. So those are the pieces that you would add together and set equal to whatever 5 minus 2 times 180 is. Yes? Yes, counting sides, counting angles. N technically means number of sides, but however many angles you have is going to be the same as the number of sides. Yep, that is a great question. All right, let's look at number 2. Again, I'm only going to do one of these. I'm only going to do part A. I'm going to leave part B for you guys to do on your own. We want to find the measure of each interior. Remember, that was n minus 2 times 180 over n, and each exterior angle, that was 360 divided by n. For a regular hexagon, how many angles and sides does a hexagon have? 6. So n equals 6. So for interior, we would do 6 minus 2 times 180 divided by 6. That would give me 720 divided by 6, which comes out to be 120 degrees. So there's my interior angle. And for exterior, we do 360 divided by 6. 360 divided by 6 gives me 60 degrees. And remember, these two angles will add to 180. These are a linear pair, and so they will always add up to 180. All right, number 3. Given the interior angle of a regular polygon is 160 degrees, find the number of sides of the regular polygon. So I have to use my each interior angle formula. So I have n minus 2 times 180 over n, and we're going to set that equal to this 160 that they gave us here. First thing we're going to do is get rid of the fraction, so we need to multiply both sides by n. And while we're doing that, we're also going to distribute this 180 inside those parentheses. So over on the left, the n that we multiply by and the n in the denominator cancel out. When I distribute, I would have 180n minus 360 equals 160n. I want to get my n's to the same side, so I subtract 180n from both sides. I do not subtract the 160n from both sides because that would leave me a 0 over on the right, and I don't want a 0 as part of my equation. Negative 360 equals negative 20n. And then you divide both sides by negative 20. Negative divided by a negative gives me a positive. I get 18 for n. So there are 18 sides. Give you guys a moment to catch up. And then we'll go look at questions 4 and 5. All right. Question number 4, circle all of the statements that are true, correct the ones that are false. Diagonals are only congruent in squares and rectangles. And isosceles trapezoids. So that first statement is false because you had to also include isosceles trapezoids. Trapezoids are sometimes parallelograms. That is not true. They are never parallelograms. Circles are polygons. A polygon has to be made with straight sides. So a triangle is a polygon, a square and a rectangle, those are polygons. A hexagon is a polygon, but anything with curved sides is not a polygon. So circles are not polygons. All rectangles are squares? No, but some rectangles are squares. All rhombi are parallelograms. That is true. If it meets the requirement for a rhombus, then it automatically meets all of the requirements for a parallelogram. The diagonals of a rhombus are perpendicular. That is true. Diagonals bisect each other in a rectangle. That is true for all parallelograms, and a rectangle is a special type of a parallelogram. All sides are congruent in squares only. They're congruent in a square and a rhombus. So that last one is false because you also have to include rhombi there. Number 5, define what it means for a polygon to be regular A regular polygon has all sides congruent and all angles congruent. All sides congruent, all angles congruent. That leaves one last problem on page 2. If you want to flip the page over, we'll look at problem number 6. And that will finish out the Module 7 material. Given trapezoid PQRS is isosceles, find the value of x and FG. That's part A. FG, this segment right here, which they're telling me is 5x minus 31, this is a mid-segment. It is exactly halfway in between Q and P over on the left, and in between R and S over on the right. And because it's an isosceles trapezoid, FQ, RG, FP, and GS are all congruent. Now the mid-segment is equal to half of the sum of the two bases, base 1 plus base 2. Well, up here at the top, QR 19, I'm going to call that base 1. Down at the bottom, PS 29, I'm going to call that base 2. So my mid-segment, which is FG, is equal to 1/2 of QR plus PS. So I would have 5x minus 31 equals 1/2 of 19 plus 29. What is 19 plus 29? 48. So I have 5x minus 31 equals half of 48. What is half of 48? 24. 5x minus 31 equals 24. Then we would add 31 to both sides. Move my work over here a little bit. That would give me 5x equals 55. And then I would divide both sides by 5. And I would get that x is 11. Once I know how big x is, what do I do to find FG? Substitute, yes. So I do 5 times 11 minus 31, or 55 minus 31. What's 55 minus 31? 24. So FG is 24. And then part B is talking about angles on an isosceles trapezoid. My base angles are congruent, so that means P and S are congruent to each other, and Q and R are congruent to each other. And then same side angles, so Q and P, are supplementary. R and S would also be supplementary. Says that P is 73 degrees. And Q is 2y minus 9 degrees. Because they are supplementary, they are going to add to 180. So the measure of angle P plus the measure of angle Q equals 180. So I would have 73 plus 2y minus 9 equals 180. Combine our like terms together. I would have 2y plus 64 equals 180. Then I would subtract 64 from both sides. What is 180 minus 64? 116. Then we divide both sides by 2. We get that y is 58. So we can fill that piece in. Then we also want the measure of angle R. Angles Q and R are congruent. So the measure of angle Q is equal to the measure of angle R. Angle Q is 2y minus 9. And we now know that y is 58. So I have 2 times 58 minus 9 equals angle R. So that would be 116 minus 9 is equal to angle R, or 107 equals angle R. All right. Nice work on Module 7 stuff today. For tomorrow, I need you to keep working forward in the packet. If you look there, question 7, right above question 7, it says Module 8, similarity. I need you to do all of the questions in the Module 8 section, as well as all the questions in the Module 9 section. So I want you to do Modules 8 and 9. I'm going to pass back the reviews from Modules 8 and 9 so that you will have those to help you. If I don't return one to you, then I did not receive one from you.